Welcome to Akbar Academy. In today's lesson, we'll be looking at a three-part physics question based on electric heaters using the principles of power dissipation, resistance of wires, and energy costs over time. This question combines ideas from electricity, materials, and real-life cost calculations. So it's an excellent opportunity to apply formulas in a practical context. Let's go step by step and break everything down clearly. Part A. Calculate the current in the resistance wire. We are told that an electric heater uses a resistance wire with a resistance of 26 ohms, and the power dissipated in the wire is 2,500 watts. We are asked to calculate the current, which we will represent with the letter I. Let's begin by looking at the formulas involved. Step 1. Start with the power formula. We know from our basic physics equations that power equals voltage multiplied by current. In short, P equals to I multiplied by V. This is our first formula. We also know another relationship, voltage equals current multiplied by resistance, or V equals I multiplied by R. This is our second formula. Now here's the clever part. We're going to substitute the value of V from the second formula into the first one. So replacing V in the power formula with I multiplied by R, we get P equals I multiplied by R, which is P equals I squared multiplied by R. That's the final rearranged formula we'll use to find the current. Step 2. Rearrange the formula to make current the subject. We now need to make the subject of the formula. We start from P equals I squared multiplied by R. To isolate I, we divide both sides by R, which gives P divided by R equals I squared. Then we take the square root of both sides. Current equals square root of power divided by resistance. So now we can plug in the actual values. Step 3. Substitution and calculation. Substitute the values into the formula. Current equals square root of 2,500 divided by 26. First, divide 2,500 by 26. That gives us 96.153846. Now take its square root. That gives us 9.805807. We round this to two significant figures. Current equals 9.8 amperes, so the final answer for part A is current equals 9.8 amperes. Part B. Calculate the resistance of a new wire. Now we move on to part B, which looks at the physical properties of resistance wire. We are told that the original wire has a length of 1.2 meters and a cross-sectional area of 7.9 multiplied by 10 to the power of minus 7 meters squared. This wire has a resistance of 26 ohms. Now, a new heater is made using wire of same material, but it has a length of 1.8 meters and a cross-sectional area of 5.8 multiplied by 10 to the power of minus 7 meters squared. We're asked to calculate the resistance of this new wire. Let's go step by step. Step 1. Recall the formula for resistance of a wire. The resistance of a wire is proportional to its length and inversely proportional to its cross-sectional area. This means resistance equals to K multiplied by length divided by area, where K is a constant that depends on the material. So for the original wire, R1 equals K multiplied by L1 divided by A1. And for the new wire, R2 equals K multiplied by L2 divided by A2. Let's first calculate K, the constant, using the original values. Step 2. Calculate K using the original wire. We know R1 equals 26 ohms and L1 equals 1.2 meters. A1 equals 7.9 multiplied by 10 to the power of minus 7 meters squared. So K equals R1 multiplied by A1 divided by L1. Substitute the values k equals 26 multiplied by 7.9 multiplied by 10 to the power of minus 7, then divided by 1.2. First multiply 26 by 7.9. That gives 205.4. Now multiply that by 10 to the power of minus 7. So we get 205.4 multiplied by 10 to the power of minus 7. Now divide by 1.2. That gives us 1.71166667 multiplied by 10 to the power of minus 5. So now we have the value of k. Step 3. Use k to calculate resistance of new wire. Now we apply the same formula for the new wire. R2 equals k multiplied by L2 divided by A2. We know k equals 1.71166667 multiplied by 10 to the power of minus 5. L2 equals 1.8 meters. A2 equals 5.8 multiplied by 10 to the power of minus 7 meters squared. Now substitute R2 equals 1.7116667 multiplied by 10 to the power of minus 5 multiplied by 1.8 divided by 5.8 multiplied by 10 to the power of minus 7. First, divide 1.8 by 5.8 multiplied by 10 to the power of minus 7. That gives 3.10345 multiplied by 10 to the power of 6. Now multiply that by k. 3.10345 multiplied by 10 to the power of 6 multiplied by 1.7, 116667 multiplied by 10 to the power of minus 5 gives us 53.12069 ohms. We round that to two significant figures. Resistance equals 53 ohms. That completes part B. Part C. Calculate the cost of using the heater for 2 days. In the last part, we are given that the heater operates at 2,500 watts and the electricity cost is $0.30 per kilowatt hour. We are asked to calculate the cost of using the heater continuously for 2 days. Let's work through this. Step 1. Convert watts to kilowatts. Since cost is given per kilowatt hour, we first convert the power to kilowatts. 2,500 watts divided by 1,000 equals 2.5 kilowatts. Step 2. Convert days to hours. 2 days equals 2 multiplied by 24, which gives 48 hours. Step 3. Calculate energy used. Now that we have both power and time, we can calculate how much energy the heater uses. We begin with the formula. Power is equal to energy divided by time. That means power in kilowatts is equal to energy in kilowatt hours divided by time in hours. Now we rearrange this formula to make energy the subject. Energy is equal to power multiplied by time. We substitute in the values. 2.5 kilowatts multiplied by 48 hours equals 120 kilowatt hours. So the total energy used by the heater over 2 days is 120 kilowatt hours. Step 4. Calculate the cost. Now that we know the total energy used is 120 kilowatt hours and the cost of electricity is $0.30 per kilowatt hour, we can calculate the total cost of running the heater. We use the formula. Total cost is equal to energy multiplied by cost per kilowatt hour. So 120 multiplied by 0.30 equals $36. That's all for now. Thank you for joining us at Akbar Academy. Keep practicing, stay confident, and I'll see you in the next lesson.